Okay, let's look at another example. Let's look at negative fractions. So I'm going to erase the previous problem, and you can write down negative 17 over 20 versus negative 4 over 5. Okay, so the first thing we want to do is make sure that the denominators are the same, and they're not. And since these are small numbers, I'm going to use the list method, and 20 is a multiple of 5. So when I write the first multiple of 20, which is 20, 5 goes into it. So this fraction can stay the same, but I've got to change my negative 4/5 to an equivalent fraction with a denominator of 20. And so I don't forget it, I'm going to put that negative symbol right there. Okay, so to get to 20 from 5, I've got to multiply by 4. And so I'm going to multiply my numerator by 4 as well. So negative 17 over 20 versus negative 16 over 20. So which one's larger? Well, remember we're on the negative side, which means we're on the left of 0. And here's negative 1. And if I were to divide this up into 20 parts, which is what that 20 indicates, I almost got 20 in there. And I would to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so here's negative 16 right here, and here's negative 17 right there in terms of these 20 parts. I'll erase this negative 1 and put it up here. Oh, you can't really see that. So let me just, right here is my negative 17 over 20, and right here is my negative 16 over 20. So what I want to show you is that negative 17 is to the left of negative 16. And anytime a value is to the left of another number on the number line, it's less than. So negative 17 over 20 is less than negative 16 over 20. So that's the answer to our problem there. Now, just about bookkeeping, one thing that I always do, I always keep my equivalent fractions either right above or right below the original fractions. Because when you enter your answer into my math lab, it's going to have the original fractions written. So here it's easy to know that this was an original, but sometimes we have to change both of the fractions. So just be really careful about keeping track about which equivalent fraction belongs to which original fraction. Because you can get the right answer, but then put it in incorrectly if you're careless, which is going to be the case throughout this course and throughout any math course. So you have to be super, super careful. All right, let's do one more. Negative 2/7 versus negative 1/3. Okay, unlike denominators, both small numbers, so I'm going to use the list method. I'm going to start with 7. Its first multiple is 7. 7 times 1 is 7. 7 times 2 is 14. 21 is the first multiple of 7, in which 3 goes into evenly. So 21 is going to be my new denominator. So let's just I'm going to put my negatives over there before I forget them. Okay, to get to 21 from 7, I had to multiply by 3. So I multiplied the numerator by 3 as well. So negative 2 over 7 is the same as negative 6 over 21. And to get to 21 from 3, I've got to multiply by 7. So negative 7 over 21 is the same as negative 1/3. So again, if I were to look at the number line, and I were to divide from 0 to -1 into 21 parts, I'm not going to do that because it's a little embarrassing because I can't always get it right, but if I were, -6 would be around here, and the -7/21 would be to the left of it. So that means that -1/3 is less than -2/7. Okay, so now let's look at evaluating expressions at where we're asked to add or subtract fractions. Give me a second to look at this. Okay, so evaluating expressions is kind of like cracking a code. Here is what we're told, x minus y, but we're given a key to the code. We're told that x is equal to 7/18, and y is equal to 2/9. When I plug in my values, I want to make sure that I bring down everything correctly. X, this is x, my subtraction symbol is here, and then my y is here. Okay, now, I see that I have unlike denominators, so to be able to add or subtract, I must have a like denominator. And using the list method, I can clearly see that 18 is going to be the least common denominator, because 9 goes into 18 2 times. So 7/18 is going to stay the same, but I've got to change this denominator to 18. And to do that, to get to 18 from 9, I multiply by 2. So that's what I do to the numerator as well. So 4/18 is the same as 2/9. Now I'm going to put my equivalent fraction here. And I like to set this up vertically. It just helps me keep track of it. It's easier to see for some reason. But if you prefer, looking at it horizontally, that's just as correct. As long as you're getting the correct answer, what you're doing must be right. And what is important is that you understand the underlying concepts. So if neither of these ways work for you, as long as it's organized, then use whatever bookkeeping method works for you. Okay, so 7 minus 4 is 3. And 7 minus 4 is 3. You see we get the same answer regardless of our bookkeeping method. And we also notice that this can be reduced. 3 goes into 18 6 times. So I'm going to simplify my fraction by dividing both my numerator and my denominator by 3. So the final answer, what you would enter would be 1/6. So just remember to use all of your rules, take your time, and you'll be able to crack the code of evaluating expressions with no problem.